Hey, guys, this is 10.5. It's called implicit differentiation. Differentiation just means taking the derivative. It's a fancy word for taking the derivative or finding the slope. Okay, implicit means we have an exponent of y that is not 1. So if you look at all our other examples from the past, we have had y equals, y equals, I could keep on going, y equals, or f of x, but either way, y equals, f of x equals, c of x, all that marginal, anyway, so every time we've taken the derivative so far, we've only either had y equals or f of x equals. And when you just have y equals or y with a pretend 1 in the air, as in y equals, or f of x equals, or g of x equals, either way, when you have these, you do something called direct differentiation, as in you just take the derivative directly, just with our normal rules of if you have a naked number, it goes to a 0. If you have an x to a number, you have to use that power rule where you bring the exponent down. If you have just x, his derivative is 1. If you have something multiplied, you use the product. If you have something divided, you use the quotient. So this is called direct differentiation because we start with a y to the power of 1. But if we ever have something with y and a different power, we have to use something called implicit differentiation, which takes into account the fact that we're taking the derivative of x and the letter y. Yeah, okay. So implicit differentiation happens when we have y with an exponent bigger than 1. And let's look at how this goes down. The first step says take the derivative of every piece of the equation according to the direct differentiation rules to the left. So we still use the same rules to the left of all of this stuff we've already learned. The only thing is, except anytime you take the derivative of y, you must write y prime. So this is pretty much the same thing as what we were doing, only now we're going to be writing y prime a couple of times. Like, for example, in direct differentiation from 9.5 to 9.4, we might have had y equals 3x squared plus 2x. Okay? And when we took the derivative of that, it became y prime, because when you take the derivative of y, you put a y prime, yeah, okay, equals, bring the 2 down in front, 6x plus the 2x just goes to a 2. So this was direct differentiation, where you just use our normal rules on the x's, and the y becomes a y prime when you take the derivative. Well, same thing here. We're going to use our regular direct differentiation rules that we just used on the left, and we're going to write y prime every time we take the derivative of y. The only difference is we're not just going to have y equals 3x squared plus 2x. We're going to have maybe y cubed minus 3x squared equals y squared plus 2x, or something like that. We're going to have more than one y in the problem, and his exponent is not going to be a pretty one. And every time I take the derivative of the letter y, I do it the same way I normally do. I bring down the 3 in front, subtract 1 from the exponent, but then I tack on a y prime. Okay, let me show you. Like if I start with 5y squared, I take the derivative like normal. Bring down the 2, multiply it with the 5, and get 10y, subtract 1 from the air, 10y to the 1. Yeah, okay. So 10y. So this is the DD, direct differentiation. But then, since I took the derivative of y, I have to write times y prime. Yeah, so we don't have to put times x prime every time we take the derivative of x. It's only y's. Like, for example, look here. 5y, the derivative is just 5. Yeah, that's from direct differentiation rules. But since I took the derivative of y, I have to put y prime. Or if you look at this sucker, I have 3y to the 4th, and his derivative is 12y to the 3 with a y prime tacked on. If you look at this 2x to the 5, his derivative is 10x to the 4 with no x prime tacked on. We don't have to put x prime. Then lastly, we have negative 4y squared. And the derivative of that is negative 8y, but you have to tack on a y prime because you took the derivative of a y. Okay, and then the rest of the homework will give you a point, and it says evaluate for this point. So to do that, after we get our derivative, we get y prime alone by using SADMEP, and then we plug in the numbers they gave us into our equation, and that's the answer. That's the slope. So let's do this example right here. It says use ID, that's implicit differentiation, to find y prime. Then evaluate for 310. And I gave you this equation. Okay, well, let's go. We're just gonna do our normal derivative rules, but anytime I take the derivative of y, I have to put y prime. So this 8x squared just becomes the 2 comes down in front and multiplies, and we get 16x. But then this minus y cubed, I bring down the 3 in front, multiply it with that negative, and you get negative 3y. You subtract 1 from the air to the 2. But then, because I took the derivative of the y, I have to tack on y prime. Okay, and then the derivative of 3 is just gone to a 0. So I don't have to write it. And then it looks like I have an equal sign, and then another 0. Well, the derivative of 0 is still 0. Well, I have to write something here because it's the other side of the equal sign. So I'm going to put 0 because the derivative of 0 is 0. I did not have to put the 0 to the left of the equal sign because there was already some stuff there. Okay, so we just did step 1 where we take the derivative normally, only if you touch a y, you better write down y prime. Now we're on second step, get y alone by SADMEP. Okay, so if I want to get this y prime alone, I see that it has a multiply attached to it. And this 16x, it's just being added or subtracted. So if I want to use SADMEP, I'm going to subtract away this 16x so that I can get y prime by itself. And then eventually I'm going to divide to get rid of this multiply dot. So right now I'm just going to subtract 16x from both sides of the equal sign. And we get negative 3y squared multiply y prime equals 0 minus 16x, negative 16x. So we just took care of the subtract add. Now we're on the DM to get rid of this. Well, first, what are we trying to get alone? The y2 or the y prime? We're trying to get the y prime alone. So let's move this y2. It's multiplying right now, and we're going to divide him off. And we get my y alone, my y prime alone of y prime equals this fraction, negative 16x over negative 3y squared. Okay, and this represents the slope. Yeah. Okay, the last piece of the problem was we have to evaluate it for 310. This 310 is xy. So let's plug in 3 for the letter x and 10 for the letter y. And then we're going to use our calculator. -6, -16 times 3, -48, all over -3 times 10 squared, -300. Then I'm going to type both of these in and press math enter, and I get 4/25. So the slope of this janky curve at the point 3, 10, the slope is 4/25, as in we rise up, we run 25. Okay, done with that one. Let's do this next. Actually, let's do this one real quick because it's kind of the same thing. It says y minus 7x to the 3 plus 7 equals 0. Okay, so every time we find the derivative of the letter y, which is right here, I'm going to put a y prime. So since that's the only y, that's the only time I'm going to put a y prime. Okay, let's take the derivative. The derivative of a y. Well, darn, what's the derivative of an x? Well, darn, what's the derivative of 2x or 3x? Well, the derivative of 3x is 3, because that's the number attached. 2x is 2. 1x is 1. So that means y is also 1, because it has a 1 on it. 1y. Okay, so the derivative of y is just 1. But then I have to multiply by y prime to show that that 1 came from the letter y. Okay, then for the x's, we don't have to put a fancy symbol for those. We just get to it. 3 multiply that -7 makes -21, x to the subtract 1, 2. Then the derivative of a -7 just goes away to a 0. And I don't have to put that. But then on the right, the derivative of 0 is just 0, and I have to put that because there's nothing else written over here. Okay, now let's see here. What's 1 times y prime? That's a trick question. That's just y prime. And then minus 21x squared equals 0. All right, now we're going to get y prime by itself by using SADMAP. So to get this y prime by itself alone, I'm going to do the opposite of minus 21. The opposite of minus 21 is plus 21. Cancel, cancel. And we get y prime equals 0 plus 21x squared is 21x squared. Okay. And this represents the slope of that curve at the point 2, 7. And that 2, 7 is x and y. So now we're going to plug in a 2 for the x. So instead of this x, I'm going to put parentheses 2 with a squared. And then if I had a regular y, I would plug that 7 in for the regular y, like we did on that last example. We had a regular x and a regular y in our answers, so I was able to plug in both numbers. But here we don't have a regular y. It went away. So I don't have to plug in that 7 into anything because there's no regular y. I have a y prime, but that's different. Okay, so now I'm going to put this in my calculator. And I get 84. So the question was asking for us to use implicit differentiation, which we did when we used that y prime. To find y prime, well, we got that y prime equals at the point 2, 7. So that's when we plugged in the 2. We did not have to plug in a 7 because we did not have a plain old letter Y left. And then our final answer is 84. Okay, let's do this one above. It's pretty much the same thing, only part A says use implicit differentiation, and part B says use direct differentiation. Okay, so what that means is we're going to do the funky way we just learned for part A in the old school way to find part B. Okay, so for part A, we're going to do what we've been doing. Every time we take the derivative of a y, we have to put a y prime. So let's go. 8x to the 3 becomes 3 multiplied by the 8. 8, 16, 24. 24. X squared. Don't put a fancy symbol because we only have to do it with y prime. Then keep going. The derivative of negative 6y is just minus 6. But every time I touch a y and take the derivative of him, I have to put y prime. Then the derivative of 18 just goes away to 0. And then we have equals. What's the derivative of this last 0? It's still 0. So I didn't have to put that first 0 because there was already stuff to the left of my equals. Okay, now using indirect differentiation, we just did that. Now we're going to get y prime by itself. So subtract 24x squared, subtract 24x squared, cancel, and we have negative 6 multiply y prime equals 0 minus 24x squared. That's just negative 24x squared. And then to get y prime alone, we're going to divide because that's opposite of multiply. And when you divide, pick up your whole negative, pick up your whole negative, pick up your whole negative. Okay, divide. And we get y prime equals negative 24 divided by negative 6 is plusative 4 x squared. Hey, we just found y prime using indirect differentiation. Okay, now we're going to find y prime using direct differentiation. Okay, to use direct differentiation, first we have to make this equation look like everything we've had in the past. As in, it looks like y equals, or f of x equals, or g of x equals, or y equals. Anyway, we have to get y by itself first. So for direct differentiation, we have to start out with y equals first. Well, we don't. Let's do it. So I'm going to rewrite this sucker. And I'm going to get y by itself. So let's get y by itself slowly. I think I'm going to minus off this 8x to the 3. And I think I'm going to go ahead and add this 18 and get two things gone at once. So goodbye the x to the 3, goodbye the 18. All we have now is negative 6y equals this red stuff. Negative 8x to the 3 minus plusative 18. Okay, and we have not taken the derivative yet. We're just trying to set it up for y equals so that we can do direct differentiation. So now we're going to say, what do I do with this negative 6? It's multiplying, so let's divide. And don't forget to divide everything on the right by negative 6. Okay, so we get y equals, let's see, negative 8 divided by negative 6. If that's a pretty decimal, I'm okay with us writing it down. Negative 8 divided by negative 6. Oh, it's not a pretty decimal, so I'm not okay with writing that down. Let's press math, enter, enter, 4/3. So this is 4/3 x to the 3. And then now let's divide this 18 18 divided by -6 is -3. Okay, so far we have not taken any kind of derivative. All we have done is set it up for direct differentiation, as in we have y equals. That's when we can use direct differentiation, when we have y to the pretend 1 equals. If I don't have y equals, I have to use indirect. Okay, so anyway, let's take the derivative of this. Just using our normal stuff. Okay, so to show the derivative, we're going to say y prime. If we had f of x, it would be f prime x. Okay, equals, now I'm going to take this 3 in the air and bring it down in front and multiply. So 4/3 times 3, x to the subtract 1 from the air, 2. And then what's the derivative of a -3? It just goes away to 0. Okay, so let's multiply this, and it should clean up nicely. So 4/3 times 3. 4/3 times 3. 4. So this gives me y prime equals 4x squared. And you can see that implicit differentiation and direct differentiation turn out to be the same thing when you have a y to the pretend 1. If we had a y to the pretend 2, it would not be the same. We would have to do something different. Okay, I think the last one, the last two that I've been avoiding are the